Randley says, good game. Thank you. GG indeed. Okay, so now that I've burned my brain out, let's take a look at day 20. Day 20, Grove Positioning System. It's finally time to meet back up with the elves. When you try to contact them, however, you get no reply. Perhaps you're out of range? You know they're headed to the grove where the starfruit grows, so if you can figure out where that is, you should be able to meet back up with them. Fortunately, your handheld device has a file, your puzzle input, that contains the grove's coordinates. Unfortunately, the file is encrypted, just in case the device were to fall into the wrong hands. Maybe you can decrypt it? When you were still back at the camp, you overheard some elves talking about coordinate file encryption. The main operation involved in decrypting the file is called mixing. Encrypted file is a list of numbers. To mix a file, move each number forward or backward in the file, the number of positions equal to the value of the number being moved. Okay, the list is circular, so moving a number off one end of the list wraps back around to the other end as if the ends were connected. For example, moving the 1 in this sequence moves it 1 position forward because it's a 1. Okay, to move the -2 in this sequence, we move it backwards, wrapping around. Okay, so it's just mod. All right. Numbers should be moved in the order they originally appear in the encrypted file. Numbers moving around during the mixing process do not change the order in which the numbers are moved. All right, so we just need a copy. Okay. Get input. 2022, day 20. How bad is it? 5,000 lines. Ouch. All right. Actually, that's not too bad. Even 5,000 squared shouldn't be that difficult. Okay, so let's create a mod. Our usual routine here. And let's see if I can type mud instead of mud. Good. Day 20. All right. Bacon. Anzu says, since I'm just learning Rust, most of my time is spent arguing with the compiler. Yeah, that's definitely part of the steep learning curve that Rust has. But once you internalize that, it gets easier. I'm still kind of baffled by lifetimes and stuff, although I get it right most of the time now. Let's grab the test input. And read those in as numbers. Let AOC lines equals AOC lib read lines. Test input dot text. And then we're going to just store the data here. Data is a vec of, I don't know, I64s. So now self data equals lines dot dot map number dot parse collect vec. Let's see if that works. Can it figure it all out? Oh, it already is lines. It's iter. Sorry, it was already a vec. Do I have to explicitly say I64 here? Oh, I have to unwrap. Let me try changing this back to an underscore. Yeah, that likes that. Okay, so now part 1, we'll just print those out. And make sure we read it. All right, that looks right. The initial state is 1, 2, -3, 3, 2, 4. Okay, so basically we go through 1. So the 1 moves up forward 1. Then we have to get the 2. Huh. and move it forward 2. Then we get the -3, which is now over here, and move it back 3. All right. So we need not only the number we're going to be dealing with, but its original position in order to walk the list. They're all unique. Do we need to know does the real input is also all unique? Because if it's all unique, it makes it easy. We could just look it up. It's O of n each time, but and then moving it is O of n, right? Let's do this. Sort. Oh, no. Right there, I see 1066. So they're not unique. CodeMonk says, not really, it has duplicates. Yeah. Okay, so here's what I'm going to do then. Enumerate map n dot 0, n dot 1, oops, parse. So now we should get a compilation error. Oh, because I forgot to close the tuple. There we go. Now we should get, each one of these should be unique now because I've tagged them with a unique integer, right, using the enumerate. Okay, so part 1 then is result is self data clone. And what we're going to do is walk data and modify result for D in self data. And D is going to be a unique parameter. So now what we need to do is find where that number is in our list. Right? Let position is equal to result iter position n is equal to D. Unwrap. I'm going to assume it exists. And now we need to find out its new position is going to be equal to oh, right, these are all okay. So I actually want this to be I64 as well. And then we can just deal with the wrapping separately. So the enumerate is going to be n0 as I64. All right. So the new pos is equal to pos plus d dot 1. Oops. As I64. Yeah. All right. So what do we do now? Now that we have the position it's in and the position we want to put it at, we need to make sure that new pos is in range. If new pos is less than 0, then we say new pos plus equals self data len as I64. If new pos is greater than or equal to self data len, let's grab the len. Let len is equal to self data len as I64. Len. If new pos is greater than or equal to len, then new pos minus equals len. All right. Now we know it's where it needs to be. Or we know new pos is where it needs to be. If we're going to move it to the left, then we want to remove it from the old position and insert it into the new position. If we're going to move it from like, yeah, we're moving 1 from 1 to 0. If we remove it from its location, right? So we can say let val is equal to result dot remove pos. That's usize. And then we say result insert val at new pos, right? And that should just move it, right, like that. And then let's just for fun, let's print out each result as we do the moves so we can see where I've failed. Oh. Oh, I got it backwards. Okay. Slacking time. Thank you for the follow. Thank you very much. Much appreciated. Okay. So we should have something now. The final answer is, oops. All right, let's see. Did the one get moved correctly? Oh, it did not. So we should, let me print out what we're doing. Because obviously I miscalculated something. Moving pause to, oops, to new pause. There we go. Moving 0 to 1. Oh, that's backwards. Right, because we're looking for, oh yeah, no, that's right. Okay, let's print it out because obviously I'm missing what's going on. Maybe it'd be easier if I could just print it out without all the indices. And that way I can compare it more readily. But it starts off as 1, 2, negative 3, 3, negative 2, 0, 4, right? And it goes to 2, 1, negative 3, 3, negative 2, 0, 4. That's correct. The next line is 1, negative 3, 2, 3, negative 2, 0, 4. Yep. Then this line is 1, 2, 3, negative 2. Ah, okay. So it's saying moving 1 to 5. So it should be, and it should be moving it to 1, 2, 3. It should be moving to 4. Why is it getting it wrong? Oh, I see why. Because we're pulling out the old one, and now the new one has one less for for wrapping consideration. So we actually, I don't know about this line here. This looks wrong. 1, 2, negative 3, 4, 0, 3. Oh, okay. Oh, no. It just put it there at the end, at the beginning. So we just need a special case, that one. Cowface Dude, hello. Cowface Dude said, off by 1? Yep, off by 1. You're absolutely right. So it's setting it to 0. If new pause... Can we insert 1 past the end? Maybe if I do that, will it put the negative 2 at the end? No, it won't. The question is, does it matter? Let's find out. What are they even asking for? I know what to do mixing now. Then the grove coordinates can be found by looking at 1,000th, 2,000th, and 3,000th numbers after the value 0. Wrapping around the list is necessary. After the value 0. Okay, so we find the value 0 and then, okay, got it. The example above is 4 minus 3 and 2, which produces 3. All right, well, let's try it. Because what this is saying is that it doesn't matter whether the 2 is at the beginning or the end. It could be at the beginning, because all we care about is where's the 0. and then go 1,000 numbers after that. So maybe we can live with this. Let's do this here. Let 0 is equal to result dot iter dot position of. We're looking for where the 0 is. Yeah, p, where p dot 1 is equal to 0 on route. And now we just want to add up those three values, which is going to be result of 0, 0 plus 1,000 mod result len, right? And then add come on. My fingers are trying to go faster than my brain. D plus plus, and then change this to 3 and 2. And it doesn't format because I have this here. All right, is that right? Result 0 plus 1,000, 0 plus 2,000, 0 plus 3,000 mod by the len, and just add them up. Monk says exactly. I think it doesn't matter as long as the list is in the correct order. Oh, good. Good. All right, let's see if we got 3. We did not because I forgot that you don't put a semicolon in my framework. And now we can't add I64. Oh, dot 1, dot 1, dot 1. We're adding up the numbers that are in those positions. And do we have a 3? We have a 3. All right, I'm going to get rid of these print lines, because 5,000 numbers getting dumped out like that will generate a ton of data. Okay. Let's go for the real input. 20, 22, 20. Whoops. Oh, okay. Oh. Yeah, that adds len plus 1. That adds len minus 1. All right, we're going to have to switch back to the test input just to make sure I don't break anything. But this is inserting at -1, which obviously should be 0. Is that where this comes into play? That's 3, so it doesn't break. Nope. Yeah, if I just say -1 here. Can I do this? Can I do this? Can I say this? Mod len. I don't know if it's supposed to be len or len. I came up with an answer. I don't even know if that's right. Let me see if that's right. 17,490. That's still 3. That's still 3. Good Monk says, I think the problem is real input numbers wrap around. Yeah, I was just trying to figure out how to do the wraparound correctly. That was the trick. So let's see if this is right. At least it's not panicking. Yay, that's the right answer. Okay. Part 2 is the Grove coordinate values seem nonsensical. While you ponder the mysteries of ELF encryption, you suddenly remember the rest of the decryption routine you overheard back at camp. First, you need to apply the decryption key. Multiply each number by the decryption key before you begin. This will produce the actual listed numbers to mix. Second, you need to mix the listed numbers 10 times. So it has to be fast. All right. Well, this isn't too bad, right? It only took 0.3 of a second. The order in which the numbers are mixed is not changed during mixing. The numbers are still moved in the order they appeared in the original premixed list. So if -3 appears fourth in the original list of numbers to mix, -3 will be the fourth number to move during each round of mixing. Oh, I see. So you started with this initial arrangement. You do one round of mixing, but then you still mix them using this number first. Well, the good news is we have test input. Oops. All right, so what we need to do then, let's commit this change. Git status, git add source, git commit 2022 day 20 part 1. Okay, and now what we can do is refactor this code here to give it the decryption key, because we have to multiply each value by the decryption key, and how many rounds to do. So let's just create a simple mix decrypt, which takes data, which is a vec of I64, I64. It takes in the rounds, and it takes in a key, which is I64. It returns an I64. So let's extract all this like that. Oh, what's the answer then? Is the answer still? It is. Okay, here the 1000th number after 0. Okay, okay. So the answer is the same. So we can use the same calculation. Just do that. And then instead of self data clone, we just say data clone. And instead of data clone, what we're going to do is we're going to say data iter map AB, actually index and value. Let's just use real names. And it's going to map to index, comma, value times key. Collect. And it's just going to be result len. D in data, like that. Oh, and then we have to do number of rounds. 4 in 0 dot dot rounds. Actually, let's just call it decrypt self data 1 round, and the key is 1. Still doesn't like it. Oh, because I missed a vertical bar. There we go. Anonymous says, need to be careful with mod in Rust. It's not actually quite modulo. Oh, okay. We need a Euclid-based... Oh, because if this goes negative, is that what you're saying? If this goes negative, that's... Well, I mean, that kind of handles that case. Yeah, Euclidean modulo is always a positive number, right? Whereas in Rust, I'm guessing based on what you're saying is that a negative mod is a negative mod. But hopefully that will handle that case. All right, so decrypt, so it should still say 17490 if we run this. And it doesn't because I messed this up. Now we can't compare. Oh. Oh. We don't want to have, what it's saying is I can't compare the reference there. So basically we just need to copy in the index. That's the answer to that one. Okay, so it still says 17490, so we did that right. So part 2 should be decrypt self data, whatever that key was. Here it is. Right. Should I run this outside? Look at that. We got a none value, 48. Are we missing something? It couldn't find... It couldn't find the value? After one round. Why? This is a reference to a vec, so we should be able to find... What is it not able to find? What am... Oh, what? Oh, right. Duh, because we're trying to actually find the... Oops. Let's do this. This is probably overkill, but... And then this is just data clone. And now data is this, so D is this, so that means we can put an ampersand there, and this gets used up, and that means this has to be, so what is this? That's an I64, I64, okay, so now we can do that. What was somebody, Anzu was saying, fighting with the compiler? All right, we got a very big number. Oh, I want to use the test data first. Let's use the test data first, because that... Oh, let's just try it. Let's just try it and see. And if it's wrong, then we'll go back to the test data. Oh, it's right. Okay. Who needs test data? Puh. Amateurs. Okay, so round. Oh, I did delete it already. Okay. All right, that's day 20. Lodmo says, I recommend reading this explanation on the mod versus REM Euclid. Okay, I will definitely check that out. Thank you, Lodmo. All right, do I have enough time for day 21? I really want to get day 21 done.